Assalamualaikum and good day everyone. My name is Mohamad Hafizie bin Kudus. My supervisor is Dr. Zuliahani binti Ahmad, and I want to present my final year project entitled Epoxy filled with Microcrystalline Cellulose Primer Coating with addition of Silane coupling agent on metal substrate. Chapter 1. Introduction. Epoxy primer coatings are utilized for a wide range of materials because of their great adhesion, mechanical ability, and chemical resistance in wet and high humidity setting. MCC is made from high-grade purified wood cellulose. Hydrolysis process is used to remove cellulose until the microcrystalline form remains. Silane coupling agent is compound whose molecules contain functional group that bond with both organic and inorganic material. Ultrasonication mixing is a method of distributing the filler in the epoxy coating. It enters delivering alternating pressure in the solutions area over the cavitation production threshold induced by an acoustic wave. The problem statement of this study is corrosion is the destructive attack of a metal by a chemical or electrochemical reaction with its environment. Corrosion degrades important structures such as steel reinforced highway, electrical tower, parking structure, and bridge. The addition of microcrystalline cellulose (MCC) to the primer coating is believed to improve the strength of the epoxy primer system due to its high crystalline structure, but it has a poor interaction between the epoxy primer coating and metal. The objective of this study is to determine the optimum sonication time of epoxy primer coating filled with MCC on its mechanical, physical, and corrosive properties, to study the effect of various Silane coupling agent loadings on its mechanical, physical, and corrosive properties of epoxy MCC primer coating. Chapter 2. Literature Review. The thickness of an epoxy primer affects its ability to resist corrosion. The better the protection, the thicker the epoxy primer coating. The influence of microcrystalline cellulose particles on the mechanical properties of an alkaline treated jute fabric reinforced grain epoxy composite. It was discovered that incorporating MCC particle into a woven jute cloth reinforced epoxy composite had a favorable effect. It improved mechanical characteristics up to 7% loading, probably because of a good MCC epoxy matrix interface and the resistance afforded by particles to fracture initiation and propagation. The addition strength of epoxy paste coating to mild steel treated with various mix of 3-aminopropyl triethoxysilane test and tetraethyl orthosilicate (TEOS). When compared to the untreated one, the addition strength increased by 55% from 3.5 MPa to 5.3 MPa with no change in the fracture mode. Sonication is a unique approach for dispersing filler in resin. Hardness rises as the sonication amplitude rises. As the amplitude increases, the ultrasonic wave come into contact with a greater number of agglomerates, improving dispersion and resulting in increased hardness. Chapter 3. Methodology. Methodology. The first method is FTIR. FTIR is to identify and analyze the chemical structure of epoxy primer coating. Immersion test is to study the adhesive strength of the coating filler with the metal substrate. Pencil hardness test is to determine the mechanical strength of coating, and Teffer polarization method is to measure the corrosion rate of coating. Chapter 4. Results and Discussion. This 3P is important because it shows that MCC uptest was born into epoxy resin. This is the result for immersion test. It shows that epoxy MCC at 30 minutes sonication time, the corrosion is not aggressively happen. For pixel hardness test, it shows that MCC epoxy at 30 minute sonication time, the hardness is increased from 4H to 5H. When addition of uptest up to 7%, the hardness is increased from 5H to 6H. Epoxy MCC at 0 sonication time, the corrosion rate is 1.91 mm over year and the polarization resistance is 556.58 ohm. Up to 9% of uptest, it gives the lowest corrosion rate, which is 0.004 mm over year, and the highest polarization resistance is 198.9.69 kilo ohm. And last but not least, conclusion and recommendation. In conclusion, it proven that surface treatment of MCC with uptest shows good compatibility with the epoxy resin when added as a filler when analyzed using FDR. The immersion test shows that up to the 30 minutes of sonication time give the optimal result when the corrosion does not aggressively happen. The uniform dispersion of MCC fill the holes in the coating, making the coating resistant to corrosion. Pencil hardness test up to 30 minutes sonication time, it does increase the coating resistance towards scratch from a pencil on a metal substrate, which can be seen at hardness of 5H. But with the addition of Silane coupling agent, which is uptest at 30 minutes sonication time, it increased the hardness from 5H to 6H. Therefore, polarization method, the corrosion rate value for epoxy MCC at 30 minutes sonication time is 0.59 mm per year, and the polarization resistance is 148.06 ohm. It's found that the addition of uptest up to 9% gave the lowest corrosion rate at 0.04 mm over year and the highest polarization resistance at 198.69 kilo ohm. Recommendation. Future research could be done to improve the effectiveness of primer coatings for metal corrosion protection that contain epoxy and MCC treated with Silane coupling agent. According to environmental factors like humidity, temperature, and various coating thickness, testing can be investigated. This is a result of the element that could have an impact on how well the primer coats work. To achieve the ideal loading, it is also advised to repeat the various uptest loading methods, as it is known that the presence of chloride ion can damage the protective function of the coating. Varied concentration of salt solution can be utilized to measure the rate of corrosion for further study. As corrosion tends to change the weight loss of the coating, investigation on the characterization of the thickness measurement of coating before and after immersion in various salt solution are essential to ascertain the attributes and performance of the loading. Other than that, by incorporating a self-healing ingredient into the primer coatings through a method called microencapsulation, self-healing coating is advised. Polymeric materials could be implanted with microcapsule containing a self-healing agent. When fracture develops, the microcapsule will open, allowing the healed agent to flow into the matrix and repair the scratches. This method can be used to create the protective primer layer that perform well.